question 1. The diagram shows part of the graph of a quadratic function y equals f of x. The graph has an equation of the form k bracket x minus a bracket x minus b. What's the equation of the graph? This functions from graphs question. First of all, if we've got a root at 1 and a root at 4, that's generated by bracket x minus 1, x minus 4. So we can immediately eliminate b and eliminate d, so we're between a and c now. We've got another point in the question, which is 0, 12. So what we know there is when x is equal to 0, y is equal to 12. So now we can work out the value of k. So where is y, I'm going to replace it with 12. And where is x, I'm going to replace that with 0. Minus 1 times minus 4 is 4, so that's 12 equals 4k. And k is equal to 12 divided by 4, which is 3. Therefore, the correct answer is option A. Okay, section 5, question 2. The diagram shows a sketch of functions f and g where f of x equals x cubed plus 5x squared minus 36x plus 32. And g of x equals minus x squared plus x plus 2. The two graphs intersect at the points A, B and C. Determine the x coordinate of the 3 points. Right, so for that one, we can do a bit of y equals y there. So we can make the functions equal to each other. X cubed plus 5x squared minus 36x plus 32 is equal to minus x squared plus x plus 2. Now from there, we can bring everything across, make equal to 0, so it's going to be x squared, x cubed, minus x squared will come across, become plus x squared, so it's plus 6x squared. Plus x will come across, become minus x, so that's minus 37x. Plus 2 comes across, becomes minus 2, so plus 32 minus 2 is plus 30, and that's equal to 0. Now for this one, we're going to use synthetic division. The synthetic division questions, in terms of factorising, quite often we get a prompt with that question, i.e. x minus 1 is a factor, x plus 2 is a factor, that kind of thing. We don't have that with this one, so what we do is we look at the last number, and numbers that could work are all your positive and negative factors of 30. Now I'm just going to have a quick look at the curve, and I'm just going to take a guess, I could be right or wrong, that the x coordinate there might be 1, so I'm going to try 1. So 1 up the side, I'll keep a wee eye out for 0 coefficients, but there's none. So that's 1, 6, minus 37 and 30. Drop the 1 down, 1 times 1 is 1, 1 plus 6 is 7, 7 times 1 is 7, 7 minus 37 is minus 30, times that by 1, and that's minus 30, and it worked. Alright, so r equals 0, therefore x minus 1 is a factor. Okay, so I've got my first point in the intersection, which is definitely 1. So that gives me the bracket x minus 1. And I get a quadratic coming out of this one, so it's going to be x squared plus 7x minus 30. So two numbers that multiply together give minus 30, add together gives 7, that's 10 and minus 3. So remember that this thing is equal to 0, because I brought everything across to make it equal to 0. And that will give me x equals 1, x equals minus 10, and x equals 3. And that's the final result. Okay, section 5, question 3. The diagram shows a curve with equation of the form y equals kx bracket x plus a all squared, which passes through the points minus 2, 0, 0, 0 and 1, 3. What are the values of a and k? Right, well, this x plus a all squared, this one again where it denotes movement to the left. So we've moved to the left by 2 units. So a is definitely equal to 2. So we're now sitting on kx bracket x plus 2 all squared. And if you think about it, that makes sense because inside the bracket is horizontal movement, and plus 2, remember, go against the grain. You're not thinking to the right with that one, but that's 2 to the left. Now what I'm going to do next is use the other point in the question, which is 1, 3. So when x is equal to 1, y is equal to 3. When x is 1, y is equal to 3, and I'm going to sub that in. So 3 equals k times 1, which is k, bracket 1 plus 2 squared, all squared. So look at 3 equals k times 3 squared. That's 3 equals k times 9. So I've got 9k equals 3, and k will be equal to 3 over 9, that's 1/3. So it's 1/3 and 2, and the correct answer is option C. Okay, section 5, example 4. Find the value of k such that the equation kx squared plus kx plus 6 equals 0 has equal roots. First thing to do there to pick up a mark is put down the condition for equal roots, which is discriminants equal 0. I'll then identify A, B and C as k, B is k, and C is 6, and then plug that in. So it's going to be k squared minus 4 times k times 6 is equal to 0. K squared minus 24k is equal to 0. That's just a simple quadratic then, so k bracket k minus 24 is equal to 0, which means I get k equals 0 and k equals 24. Just be careful at that point. This question says k cannot be equal to 0. So what you want to do at that point is to discard that result, and your final answer is k equals 24. Okay, section 5, question 5. Find the range of values of k such that the equation kx squared minus x minus 1 has no real roots. So again, let's put down the condition for no real roots, and that is the discriminant is less than 0. Let's identify A, B and C as k, B is minus 1 and C is minus 1. So b squared minus 4ac, so it's minus 1 squared minus 4 times k times minus 1 should be less than 0. Minus 1 squared is 1. Minus 4k times minus 1 is plus 4k, and that's less than 0. So, line the one across, 4k is less than minus 1, and k is less than minus 1 over 4. That's the final answer.